Hey, welcome. Sorry I can't be there today, but we're going to do this lesson anyway. So here's a video. What's the next best thing of me being there is me being on video. Anyway, today we're going to focus. Last class we focused on looking at a scatter plot and determining direction, form, and strength of an association or correlation. Now we're going to put a number to it. A number that basically defines how close our data is to a line. That line of best fit. This is called correlation. Okay? So anyway, a couple things about correlation. It's just estimating the correlation or the association between two quantitative variables in a scatter plot. We're then going to interpret the correlation, and then we're going to distinguish the correlation from causation. Are they the same? Does correlation basically say that there's a cause? So anyway, here's what we did last time. Now we're going to quantify the strength. When we define the direction, form, strength, we're going to put a number to it. And that number is called correlation, and we use the letter R to determine and to assign correlation. Okay, just get an idea. Here's the idea. Correlation is some number between -1 and +1. Okay, if it's less than 0, it's a negative relationship. As X increases, Y would decrease. Kind of like your gas mileage. If you go faster down the road, your gas mileage would probably go down. Okay? And then if it's greater than 0, it's positive. Like the more hours you study for a test, hopefully the better your test score. There's a positive association. Okay? A 1 means it's perfect in a straight line. The dots fall in one line. It's in a positive direction, and -1 would be one line in a negative direction. Okay? And if there's really hardly an association, it's hard to tell. As the correlation gets closer to 0, then it's harder to see if there's positive or negative association. There may be no linear association. So down below here are some scatter plots. This one, the first one I see, if I look at that and look from left to right, can you tell whether the dots tend to go up or down? And when it's really hard to see that in the scatter plot, then we're probably assuming that, hey, this is probably close to 0 for the correlation. Okay? Then we get a little stronger. We kind of see in the next one the dots tend to go down, so that would mean a negative correlation. And this would be an example of what a 0.3 would look like. Okay, kind of close to 0 because it's not a strong one, but that's 0.3. Then if we see the next one, they tend to go up. They're a little more obvious and closer. That's a 0.5. Now we see the next one below here is definitely one where it's definitely negative, and it's a little stronger than where the other one. That's a -0.7. And then they get really close, these next two. We have a 0.9 because it's very close to being on a line, and this one's especially close to being a single line. That's a -0.99. So correlation tells you about how close they are to a line. Okay? We're now going to try this activity called Guess the Correlation. So let's give you a chance to do this. So I'm going to show you here. There's a scatter plot. What do you think? Is it positive or negative? And then what number goes with it? So just think of a guess, and then we'll show you what it is. It is a -0.692. Pretty strong. Let's try another one. Ooh, that one looks like, is it negative? Is it very strong? What do you think? What's your guess? Negative or positive what? Looks like it'd be closer to 0 in my opinion. It's a -0.197. They tend to go down. It's not that obvious and it's not that strong. Let's look at another one. Ooh, that's a tough one. What do you think? Negative or positive, and is it very strong? What's your guess? Well, that's a, wow, 0.031. That is really close to 0. It's positive because barely maybe you can see it's positive. One more time. What do you think that one is? Well, it looks a little stronger if I'm describing it. I think that's a stronger relationship and positive. What's your guess? Well, it's a 0.86. Pretty good. So anyway, those are guessing the correlation. That's what some look like. You're not going to have to guess a correlation on a test. We're just trying to show you what appears to be kind of a strong R and what's a R that's closer to 0, what they look like in a scatter plot. So here's some correlations I bet you never guessed in a million years would have existed, or maybe they're obvious. If we compare the number of people with master's degrees ordered in education, that is a strong relationship between that and the popularity of the overly attached girlfriend meme. Bet you never thought of that, but look at how closely they're related. Wow. How about this one? Probably never thought of this one. Master's degrees awarded in technology and wind power generated in Kazakhstan. Wow, that's, look at how strong that relationship is. Bet you never would have thought those two things are related. How about popularity of the first name Edith and Delta Airlines stock price? So if you come to a year where there's a lot of Ediths, babies named Edith, buy Delta Airlines stock. What do you think? They're pretty closely related. How about the cost of sending a letter, which you maybe you've never done. It's been a long time since I've sent one. And the Google search for I am dizzy. Well, look how closely they're related. So more people sending out letters, more I am dizzy searches. Number of septic tank services and sewer pipe cleaners in Alabama. Does that correspond with the electricity generation in Antarctica? Well, I don't know. They always say poop flows downhill, and Alabama's up here, and Antarctica's way down there. Maybe they generate electricity with that stuff. I don't know. And then cigarette smoking for U.S. adults and arson in the United States. Well, I can see how cigarette smoking and fires might be related. Arson's intentional set of fire. Does that mean that one causes the other? Not necessarily. So here's an interesting one now as we look at a true correlation. Chocolate consumption. Our explanatory variables, chocolate consumption. Okay? And the Nobel laureates in these countries. So if the United States wants to have more Nobel laureates, we got to start eating more chocolate, right? Okay? Well, the question is, just because we see there's a strong relationship between the chocolate consumption and the number of Nobel laureates in these countries, does that mean that chocolate's the cause of that? Well, there's something we have to understand. Just because there's correlation is not proof that one causes the other. And so we use this term, correlation does not imply causation. It doesn't mean it doesn't cause it, but we can't assume it based solely on that. Later on, we'll learn what does cause causation. Okay, but we can't assume that. That's a term you should have written down and understand. Correlation does not imply causation. Can't assume it. Okay, so anyway, let's get started on practicing some of these. The homework problems, we're going to do them in class here. You need to do these and complete them and turn them in before the end of class. Whatever you're up to, turn it in, because you won't get credit for it if it's turned in after the conclusion of class. So have that phone ready, turn them into Seesaw before you leave class today. Hope you guys have a nice weekend. Hope it's not too scary, but happy Halloween, and we'll see you next week.